I'm Mr. McBrien. This is TEJ3M, Arduino 3, variables, and more. Yesterday we talked about the serial monitor and connecting the Arduino up to our breadboards to output electrical signals. Today we're going to talk about using variables, and then we're going to apply those ideas of variables to creating a different kind of loop from what we were talking about yesterday. So before we go any further, I'd invite you to use whatever knowledge you have of mathematics or programming or both to ask yourself what variables are for. So you can pause the video and think about that for a second. Think about what you know. So you may have decided that variables are for calculations or for comparisons. If you are a programmer, you might have thought about containing strings inside of variables or having counters to allow you to count how many times something has occurred. Also, closely related to programming is the idea of a status assigned to a variable. Done or not done, or red or blue, that kind of thing. So any of these we can use variables for them, and we're going to talk about ways to use those today. Now, depending on how you apply your variables, this will cause you to design your variable type to match the way you're going to apply it. So your variable type might be a character, not often used in Arduino, but it can be. It might be a byte, again, not commonly used. Might be an integer. There are lots of different possibilities here, and each of these are hyperlinked inside the slides, and you can go ahead and check the references in terms of how the Arduino folks have implemented this kind of thing. You might recall it was only just over a week ago that we talked about the idea of Boolean variables, and these are supported inside Arduino as well. Now, whatever kind of variable you have, a key concept across virtually every programming language is the idea of declaring variables. Before you can use it, you have to tell the system about it, what kind of variable it is, what its name is, and usually an initial value that will attack at a later point. Now, global variables are declared once, and they can be used at any time subsequently throughout the sketch. There are what's called local variables for certain situations where that variable can only be used inside a subset of your program. The syntax is very simple. If we want to declare an integer, we can just declare int and then give its name. If we want to initialize that variable, we can give it an initial value. Either one of those possibilities can be used. In terms of what names might be used, virtually any name can be used for a variable. However, you can't use something that is already known as a command, that is already a command within the Arduino language. You should remember that your variable names are case sensitive. And one thing that new programmers have trouble realizing is that we should use the possible lengths of these things and capitalization to communicate the purpose of a given variable. For example, we might call our variable number of iterations completed. This is a lot clearer than saying X, that kind of thing. And in fact, if you want to get the highest possible marks in the course, you need to be sure and include those proper variable names that communicate why they're being used. Now, I already alluded to this briefly. You should initialize variables typically to avoid potential problems within your sketch. So if you can, set an initial value for your variable. And if that fits with your sketch logic properly, then you'll avoid having crashes at some later point. Quick note about the integer type. They have no decimals, perhaps obviously. Usually they're used for counting purposes. They're very handy for that purpose. Now, if you want to do calculations in Arduino, you can think about what things you might calculate. You might, if you've got a robot, calculate distance. You might calculate speed for some purpose. You might calculate temperature if you have a temperature sensor. There's many, many different calculations that you might do. You typically use a real number for calculations. The syntax is extremely simple. So, for example, if we want to do addition, calculated value equals value 1 plus value 2 is our syntax for that kind of thing. It's all pretty straightforward. Division, of course, uses the slash. You can look up all those kinds of calculations. Things like exponents, etc. are supported. Okay, so yesterday we talked about how to use the serial monitor. Today, I'd like you to use the calculation function. Rather than put a whole bunch of hardware onto your Arduino, just simply use your serial monitor to retrieve the user's age, convert it to days, and tell them back how old they are. In terms of, as a reminder, in terms of how to get your value from the serial monitor, remember you need to open communication with the serial monitor and you need to retrieve that stuff. It is a good idea to communicate to the user what you're expecting. Go ahead and retrieve the reference for that as you need to. So when you've done that piece, you can come back here and we'll talk a little bit about loops. Okay, welcome back. So part 2 around loops. Remember, we learned yesterday that Arduinos will repeat the loop section over and over again. And so you might say, well, why are we even talking about that again? And the answer is that not all loops continue forever. What happens when we want a given activity to stop once there has been a solution to the problem, once something has happened? So the simplest example of this kind of loop is a for loop. And every programming language I've ever heard of supports the idea of performing a function a number of times. In the Arduino, we have this for loop here. So if we want to run our given loop a certain number of times, in this case 100 times, we move our counter, our integer x, from 0 up to 99. Notice this less than 100. And this portion of the statement tells it that it needs to go up. And so this loop will run 100 times. It will print the value of x. Pretty standard loop. So for loops typically do this kind of thing. When could we use this in an Arduino? You might imagine that a wheel might want to turn around 3 times, for example. But in fact, those kinds of loops aren't very common with Arduinos because it's not often that we're sure how many times we want to perform a given function. Rather, we want to use the power of the Arduino, its ability to sense its environment, so we want it to react to its environment. So for this, we use conditional loops. So examples of conditional loops would be keep moving forward until a bump sensor is triggered, move the robot arm down until the laser beam is blocked. Lots and lots and lots of other examples, including, by the way, monitor the serial monitor until there is an input. So we do these things using what's called a while loop. So the while loop will keep iterating as long as a condition is met. So the sketch keeps checking the condition, and it keeps going, checking and checking and checking until the condition is no longer true. For example, while the temperature is below 100 degrees, keep applying power to the heater. Okay, so I alluded to this previously. We can wait for the serial monitor. Our while loop here waits. In this case, we can see while serial.available is 0, it continues to check. Once that value is not 0, then in this case it's attaching the age in years. So this is our implementation of our retrieving the age in years. Okay, so we can do many kinds of things with those while loops, waiting for situations to change. So our second activity is implementing from the while loop, the online while loop tutorial. This is a very cool nightlight function in that it includes calibration of the device. So it checks for the button to push, and when the button is pushed, it monitors a given pin to set a calibration value, which is then a reference for future running of the device. Now, you might have been jolted a little bit about that because we haven't talked about reading values from a pin yet. That nightlight implementation reads the value from the pin to decide if it's dark. Well, we're not going to cover reading inputs from the pins for a couple of days yet, so I invite you to just sort of gloss over that portion of the code. I want you to more look at the while loop that's inside that code. And of course, the other fun thing about it is building the circuit itself. Okay, so that's pretty much it for today. We've gone through some variables, talking about how they might be used, talked about variable types, and that we need to match the application to the variable type. We talked about variable declaration and initialization. And we've talked about the idea of loops not running forever and the idea of a while loop that continues until the condition is no longer met. So for your homework, please go ahead and do the age conversion sketch, do your nightlight implementation, and essentially pour through some of these references to have a look at how these things work. And as always, it's useful to, as you're looking at the references, think about how you would implement them inside your own ideas for devices. I hope this helps. Thanks very much. Have a great night.